Hi guys, welcome to our Unit 3 Systems of Equations test review. Remember, some of these questions will be exactly like the ones on your test. Some of them will be similar, but all of them will be good examples for you to use for corresponding questions. This is systems of equations, and most of us remember or should remember systems of equations from Algebra 1. And if you remember, the easiest way to solve a system of equation is when you can throw it in that graphing calculator and it gives you a beautiful answer. And so that's what I did for most of these. So if you look at my questions for number 1, 2, and 3, I put in the Desmos graphing calculator. And if you need to, you can pause the video or pull up the PDF and take some time and see exactly how I put it in the calculator. You will notice that what I put in for my equation is exactly what it's given me. I don't solve for y, nor do I need to solve for any variable. And that last tab where it says label, that's just me identifying the intersection. You don't have to do that. It's going to do that if you click on the 2 lines, okay? So those are examples of, let's see, that's 1, 2, 3, 4. That's number 4, and that's number 5 right there. And you can see once again whether it's in standard form or slope-intercept form or no form at all. As long as you put it into Desmos, it's going to give you an answer. Okay, we don't have to do the other solving method, substitution or elimination, until we get to the 3 variable ones where we would need a 3D calculator to do these. And there is, of course, a 3D Desmos calculator, but it would take me longer to teach you how to use that calculator and derive the answer than just to review the methods of substitution that you can use in order to solve these. So if you notice already, there's a problem. We have 3 different variables, and in order to solve them, the easiest thing is to try to get it down to 2 variables. So how do we do that? What I'm going to do is solve for y. So I'm going to take this first one, this first equation, and I'll just highlight it. And I'm going to solve for y. And I get y equals, I'm going to move everything to the right side. So I'm going to switch the 2x to a negative 2x. And I'm going to switch the z to a positive z. And then minus 3. Okay, so now that's been converted to an equation where I'm solving for y. I can plug that y in to any of these other 2 equations that also have a y. So if I look at this second equation right here, where this y is, I'm going to put in minus 2x plus z minus 3. Okay, so what I like to do is color associate things so that I don't get too confused. So I'm going to make this my pink function. And right where you see y, I'm going to plug in a green function. So I have 5x. Blue. 5x minus 2. Now here's the y. Minus 2x plus z minus 3. Okay. Close parentheses and then continue with writing the function. Plus 2z equals 24. Now you can't leave that like that. You need to clean it up, distribute, combine like terms, and all that good stuff. So that's what I'm going to do. (5x) plus 4x. I'm distributing this 2 throughout the equation, okay? It's going to be a minus 2z minus So that's plus 6 plus 2z equals 24. Go ahead and clean this up some more. If you notice right here, the 2z minus 2z and the plus 2z cancel out. I can combine the 5x and the 4x. I'm just checking my work to make sure. And I get 9x plus 6 equals 24. Subtract 6 from both sides. I get 9x equals 18. Okay. And then I have to divide 18 by 9, and I get x equals 2. Once I have that x equals 2, I can plug the 2 in. I'm going to plug it in and solve for z. Okay. So for this last equation, look at my blue equation. I'll plug in the 2 for x. So I have 3 times 2 minus z equals 5, or 6 minus z equals 5. And then go ahead and solve for that, and I get z equals 1. And you can probably guess what we're going to do now that we have the x and the z. I can go back to my first equation if I wanted to. You could actually use any of them that use all of them in order to solve for y. So I'm just going to go back to the first one and plug in my variables. So 2, x is 2. Don't have y. Okay. Minus 1 equals negative 3. So 4 plus y minus 1 equals negative 3. And that's going to be y equals negative 6. Okay. So this was my step 1 right here. First, I solved for x. Then I plugged it back in, my second step. I solved for z by plugging in my x. And my last step was to solve for y. Okay, check my answer. There it is right there. We plug it in x, y, z. All right, let's go to the next one. Okay, so in this next one, it's a little bit more complex because you don't have an obvious variable to solve for. So you could solve for the y or the x or even the z on any of the equations and then plug them back in. I'm going to go ahead and solve for x on the first equation and then plug that variable into the second and third equations, or that expression into the second and third equations for x, and then solve y and z as a system. Okay. All right, so let me show you what I'm going to do. Highlight this first one. And I'm going to solve it. I'm going to zoom in a bunch more. Okay. And I'm going to just move the y and the negative 2z to the opposite side of the equation so that I get as a new equation x equals y, oops, that's a negative y, plus 2z plus 9. So 9 stays positive because it's already on the right, but that's a negative y plus 2z plus 9. And every time I see x this time into these two equations, I'm going to plug it in. I'm going to plug in this expression right here, and then I'm going to simplify. I'll go ahead and simplify this. Take your time, make sure you don't mess up anything. I'm always missing a variable, especially our positive and negatives. It's got a lot of things going on. Minus 4y plus 7z plus 27 equals negative 1. I'm going to continue on, and I'm going to move everything to the right and get this where I have y all by itself. So I'll move everything to the right except for the 4y. It gives me a negative 7z minus 28. And I'm going to divide everything by negative 4. So y equals 7 over 4z, okay, plus 7. All right, so that was the green one. Now I'm going to do that for the second equation. Okay, and so that last equation, 2x plus y minus z equals 6. Okay, I'll go back and plug in my value for x, which is a negative y plus 2z plus 9. Okay. And I'm going to just solve like I did the last one. Solve for z this time. For z. I'm just checking my work. Minus 2y, 4z, plus 18, plus y, minus z equals 6. Don't keep distributing. I almost wanted to keep on distributing. So I have a negative y when I combine like terms, plus 3z, plus 18 equals 6. Now I'm going to move everything to the right side of the equation. So what I'm going to do right now is, I was going to solve for z, but I think it's going to be easier for me to solve for y. So I'll show you since y is already by itself. So I have a negative y, and I'll move the 3z and the 18 to the right side. So minus 3z minus 18 plus 6, because you're going to combine those. 2y equals minus 3z minus 12, which is going to be y equals 3z plus 12. Since I have these two expressions that are both equal to y, it's almost like we're doing elimination. Now you know y is the same thing, so I can set these two expressions equal to each other. 7 over 4z plus 7, and I can set that equal to 3z plus 12. Okay. And after doing some really quick algebra, I know y'all Some of you all don't like it, but it is what it is. It's math. So I get a negative 5 over 4. Z equals 5, or Z equals negative 4. There's my first one. Now that I have Z equals negative 4, I can actually plug this back into here for Y. So Y equals 3 times negative 4 plus 12. So for Y, I get 0. Okay. So I have my 0 for Y. And I have my negative 4 for Z. I can go ahead and solve for X. Okay. So I can go back to this original problem. Remember, we have the negative 4 for Z. So X plus 0, or you could just leave that off, minus 2. Z is negative 4 minus 4 equals 9. X, and then that's plus 8 equals 9. X equals 1. That's it. I know, I see that's it like it's easy. And I know when we're doing a lot of algebra, I don't take it for granted that I've been doing this for a long time, and it's not that easy for a lot of people to flow with all those numbers moving around. Use your resources. There's some really good matrix calculators out there that will help you do these. There's not more than one way. Like I said, there's a graphing calculator out there that you can use. There's that way. So there's more than one way to solve for these. I'll do this last one. I went ahead and uncovered the answer, just in case you're working ahead. I'll do this last one. This last one is kind of unique because you're not going to have a simple answer for Z. You actually have a range for Z. So I encourage you to find the X and the Y. You should be able to narrow it down from there and plug in to find your Z. I'll go ahead and set it up and solve now. All right, so this one is kind of a tricky one. I was playing with it a little bit because I was looking at your answer choices, and it's not fair that they give you this kind of answer choice because it's a little tricky. So I'm going to go ahead and solve it for you, show you how I do it, and hopefully it makes sense. So the first thing I'm going to do is I am going to take the equations, and what I noticed right away is that my first 3 equations looked a lot alike, right? So if I were to combine them, remember we can do that combined elimination by adding 2 equations together. So I would take my first equation, and I am going to, it doesn't matter which one you do, multiply this first equation by a negative 1, okay? And that will give me a negative 3x plus y plus z equals 9. Remember, when we multiply by a negative, it switches everything. And I'll keep my second equation just the way it is. Minus 2x minus y minus z equals negative 4. So what I notice when you combine them, the y's and the z's cancel out, and I'm left with a negative 5x equals 5, or x equals negative 1. So I went back and I plugged in negative 1 to these equations. And when I plug in negative 1 to my blue equation, I'm just going to write it, each equation plugging in negative 1. I get negative, let me make this make sense to you all so you can see them. I'm going to move over just a little bit. Okay. So I'm going to rewrite each equation, but this time I'm going to plug in the negative. And you know what? I'll write it down there so I can see. So 3 times -1 minus y minus z equals -9. Just stay with me. I'm going to do each one. -2, I'm going to plug in my -1 minus y minus z equals -4. And then I'll do my last one. 4 parentheses minus 2y minus 2z equals -16. So each of those where you see parentheses, I'm going to plug in my -1 and then just simplify or the equation. So for this blue one, I'm going to write it up here. It's going to be like 2 equations. I'll have 3, I'll show you all my steps, minus y minus z equals a -6. I'm going to move this as y, this 3 over, and I get -y minus z equals minus, that's a -3, so that's going to be a +3. Check my work real quick. I changed something up. I sure did. I changed that 9 because I was thinking ahead of the game. I knew I missed something, see? So let me put this 9 back here. It was -9, and then I added 3, and it became 6, a -6. I do the same thing with this green equation, and I get 2 minus y minus z equals -4, and I end up with -y minus z equals -6. So I noticed that my equations, when simplified, look exactly the same. Let's do the last one. This is our pink one. So -4 minus 2y minus 2z equals 12, -12. Oops. See, that's me skipping ahead again. Thinking of the answer. 16 minus 2y minus 2z equals -12. And if I divide all of this by 2, I end up with the same -y minus z equals a -6. Okay. So what that tells me is that as long as x is -1, y and z can be anything. As long as x is -1, y and z can be anything. So the fact that you have 3 options, all you need is that -1 to be the x value. I know it was confusing for me too. All right, till next time. Bye-bye.